Okay, this problem, 4.1 to 4.2 review, calculators are not allowed, number 3. This one is going to test whether or not you know your critical theorems that are supposed to be known inside and out. So by the time we get to 4.2, we know 4 of our theorems. We know our first one, which is the intermediate value theorem. That was from section 2.5. We learned our second one, which is our extreme value theorem. We learned that in section 4.1. And then we learned our third and fourth, which is Rolle's, and then the mean value theorem. Well, Rolle's is a special case of the mean value theorem. And what's critical is we need to know the conditions and we need to know the outcome or the conclusions. So we need to know what we have to have in order to get the outcome. And if we read this, it's saying what are the requirements on the function in order to guarantee these conclusions. So that means we're getting outcome information and we're asking for what the conditions are. So let's do a quick recap. For the intermediate value theorem, we have to be continuous on the closed. For the extreme value theorem, we also need to be continuous on the closed. For Rolle's theorem, we have to be continuous on the closed. We have to be differentiable on the open. And we have to have two y coordinates that are the same. Now typically we are given those conditions on the interval from a to b, but it could be any value in that interval that has the same y coordinates, because then we can just shrink. If we're continuous on the whole thing and we find two y coordinates that are the same, we can shrink it down to that interval. So continuous on the closed, differentiable on the open, and two y coordinates that are the same. For the mean value theorem, it's the same as Rolle's, except we don't have to have the endpoints be the same. So for the mean value theorem, we're continuous on the closed and differentiable on the open. So now what about the conclusions for each of those? The conclusions for the intermediate value theorem are that we have to hit every y coordinate. So we're going to have outputs at some value that equal a number, where that number is one in between the endpoint outputs. For the extreme value theorem, we get an absolute max and an absolute min. For Rolle's theorem, we get a derivative value that is 0. And for the mean value theorem, we get a derivative value that's the same as the secant slope formed by the endpoints. So when we're looking at this list of conclusions, we're seeing what do they come from and then what was required in order to guarantee them. If we look at the first one, it's a slope statement. So the only two things that deal with slope are Rolle's and the mean value theorem as conclusions. So this one is, I've got a slope that is equal to a secant slope, excuse me. So that means we've got the conclusion of the mean value theorem. That means we've got to have the criteria required for the mean value theorem. So for part A, we would need to be continuous on the closed interval, and we'd need to be differentiable on the open interval. If we look at B, we have a derivative that's equal to 0. Well, here with Rolle's, we see that the conclusion is the derivative is 0. In order to get a derivative that is 0, we have to have 3 things happening that are our criteria. So for part B, we have to be continuous on the closed, we have to be differentiable on the open, and we have to have two y coordinates that are the same. So they don't have to be the endpoint coordinates, they could be any two as long as those two are somewhere in between the endpoints and different from each other. So now let's look at C and D. They're both ending up with a minimum value and a maximum value. So the thing that guarantees mins and maxes are the extreme value theorem. And we only get the extreme value theorem if we are continuous on the closed interval. So C, we have to be continuous on the closed. Part D, same thing. It's that extreme value theorem conclusion again. And then for part E, now we're looking at a limit. So we're getting into more than just theorems, we're also looking at our derivatives and continuity definitions. So if we look at here, this is a secant slope where the 2 points are getting closer and closer together. So when that happens, we get a tangent slope or a derivative. So this is saying that the derivative exists for all values of c in the open interval. Well, that's a conclusion for if the original function is differentiable on the open interval. So this is that green page in the second packet that was stapled. So the back of it, the back of the very front page, it has your 5 important theorems and your critical definitions. So you need to know your definition of derivative, and you need to know these 4 theorems, and you need to know your definition of continuity. So far, that's what we've learned.